So, as per the last discussion, how do you use a phaser? It helps to see a real application that demonstrates it. So we're going to take a look at this example. And this example is based on some of the examples in the Java documentation for the phaser. Except what I did is I actually wrote it out in a program so you can run it, and rather than the documentation, which you just have to look at and sort of divine how it might work. So here's the test driver program. And this is in my EX26 folder in my GitHub account. And you can see here that we have a main program which creates a list of my task objects. Don't worry too much about what my task does. It's not important. It does something. I think in this case it prints some diagnostics out. We then go ahead and create a stream from 1 to number of tasks. So let's say we want to make 10 tasks. For each of those numbers, we make ourselves a new myTask object. So we use map to object, making a new myTask object. So now we have, let's say a stream of 10 myTask objects. We collect all those task objects into a list. And then we take that list of myTask objects and we first run a test that showcases a one-shot phaser. So it'll run a list of tasks that all start doing their processing at the same time. So this is using the phaser as an entry barrier. And then we also run another test that goes ahead and repeatedly runs some processing in these tasks for a given number of iterations. So let's say we say 10 iterations or 100 iterations or whatever. And this shows the use of a phaser as a cyclic barrier. All right, so let's take a look at the examples. So here's the run tasks method. As you can see, it takes a list of tasks. The first thing we do is we make a new phaser, and this phaser is given an initial count of one party, which is really the thread that's calling this thing. It's whatever thread came from here. This is the main thread, so this is going to include the main thread. We have a count for that party, so the main thread is here. And then what we do is for each task in the list of tasks, we're going to inform the phaser, hey, there's a new party to add, because this is we're about to spawn a new thread, and we want to increase the count by 1, so we register this new thread we're about to spawn. We then go ahead and create a new thread and start it, and this is going to run the task. And you can see what this does is it says arrive and await advance. So basically what it says is, block all the threads that get started. Remember, let's say there's 10 tasks, so we're going to create 10 threads, and each thread will say, I'm going to wait until everybody's shown up. And this is basically should be one-shot, a one-shot entry barrier. So we've got a one-shot entry barrier, so they all have to wait for all the threads to show up before anybody can start to run. So that's classic entry barrier style model. Once they've all shown up, then they all start to run. And then keep in mind that after this loop runs, we've got a bunch of threads that have started up, and the main thread, or the calling thread, the thread that called run task, it says, all right, I'm here and I'm out of here, so I'm going to deregister myself. And that basically says after all of these other threads have shown up, then they can all start to run. So they don't have to wait for this guy. This guy's going to deregister himself. Okay, so that's the one-shot phaser. And you can see this is very, very similar to a cyclic barrier with just some additional, syntactic sugar to be more dynamic. We don't know ahead of time, for example, how many parties there'll be. Each time we go through this loop, we register a new party. Now, you could have done a cyclic barrier on this by basically saying, task, you could say new cyclic barrier tasks.size, and you could have done a cyclic barrier that would have done almost exactly the same thing. But this is just a bit more dynamic way. Like, let's say you didn't know the number of tasks in advance. You had a stream of tasks or something like that, or a set of tasks that were coming from the user. This would be more dynamic. All right, the second example is demonstrating a cyclic barrier that repeatedly performs actions for a given number of iterations. So we have start tasks, we have the list of tasks, and we have the number of iterations that we want to actually run. And this is a more complicated example. It also demonstrates things in a slightly different way. So the first thing we do is we make ourselves a new phaser, and it's going to iterate for a given number of times. And its onAdvance hook method is used to determine when we're done. So as you can see here, the way it works is when the phase number equals the number of iterations, then we're finished. So it's going to let all these things run for the number of iterations that they need to run, which let's say is 10. And of course, if there's no registered parties, we'll also shut down. The first thing we do is the calling thread registers itself and says, all right, include me in this count. You'll notice that we didn't give the phaser an initial count. So we have to, in this case, we say phaser register. If we had said new phaser 1 here, we wouldn't have had to say phaser.register because we would have already had a count of 1. We're then going to go ahead and iterate through all the tasks, just like we did before. Somewhat like before, we go ahead and register each new thread we're about to spawn to indicate it's a party that we want to include in this phaser count. And then we make a new thread. Now, this new thread does something a little bit different from what the thread did before. If you remember the thread before, if we go back over here, this particular thing waited for everybody to show up, and then they all started to run at the same time. In this case, we're doing something a little bit different. What we're doing is once the thread starts, it's going to run its given task once. So it'll start to run. It'll run the first one. And then it's going to go ahead and say, let's wait until everybody else finishes running this task the first time. So this is kind of both a cyclic barrier and also kind of an exit barrier, right? We're going to kind of wait. After everybody runs the task once, we're all going to wait until we're all done running the first task. And then, so this is basically using this as a cyclic barrier, cyclic exit barrier is probably the best way to look at it. All right, this is important. So the last thread to call arrive and await advance will trigger the invocation of the onAdvance method. So after the last guy has had a chance to run, that will be called. And what it'll do is it'll check to see, is the phase number greater than or equal to the iterations? If it's so, the phaser becomes terminated. So it terminates when we've hit the mark. And we keep looping until the phaser is terminated by onAdvance. So when this thing is done, then is terminated becomes true, and this loop will stop iterating. So we're going to keep checking every time through this thing, are we done? If, let's say it's 10, and the first, 10 times it doesn't terminate, what it'll do in that case, it'll loop back around again. So after everybody's after everybody's done running the first phase, right, they've all done this, they all stop here, we aren't done yet, we haven't terminated, we loop back around again, and then everybody runs the run method for the next phase. And then they all block and wait on the cyclic exit barrier. And this keeps going over and over and over again until the last guy advances and the phase number equals the iteration, in which case the phaser is terminated. And then each of those loops will discover that next time they turn around and call is terminated. They'll realize, oh, we're done. We get to shut down. And then, keep in mind, all this stuff is all taking place in threads in the background. That main thread, the calling thread that went in here in the first place, after it sets everything in motion, it says, all right, I'm out of here. The other threads can do their work. Don't wait on me. I'm no longer considered to be part of this work crew, as it were. Okay, so really interesting stuff. Very complicated, obviously, very powerful, a lot more flexible. There's even other examples you can see if you read the documentation, but these are the ones that I thought were the most germane to demonstrating the functionality. So as we'll see, it's a lot more powerful, but it's also more complicated.